All right. So in this particular problem, we have a constant horizontal force of 16 Newton is applied to a stationary 40 Newton crate on a rough level surface. It says the crate reaches a speed of 5 meters per second after a distance of 30 meters. Uh, Here's A, B, and C. It asks us to calculate the acceleration, B asks us to find the time, and then C asks us to find the coefficient, aka mu k, as the crate is being pushed across this rough surface. So here's the diagram. Here's the force that's being applied, which is 16 newtons and is constant. Here is 14 Newton. I do want to point out that this is 40 Newton, not kilograms. So 40 Newton represents the weight of the crate, not mass. Okay, because the unit for mass is kilogram. But here in this particular problem, it says 40 Newton, which suggests that 40 Newton is the force of gravity. So it's the weight that's given to us already. So it's important that you pay attention to units as you practice these physics problems. You're gonna push it across a horizontal distance of 30 meters, and then by the time it reaches the 30-meter mark, it reaches a speed of 5 meters per second. So let's crack out part A and B. In order to do part A, I think the easiest way to do, based on the information given, is to use this particular kinematics equation: VF squared minus VI squared equals 2A delta X. The reason is because VI is given. It says stationary, so I'm just gonna go ahead and assume that VI is 0. In the diagram, it says V here is equal to 0 as well. Therefore, to find acceleration, we can just simplify this function down really quick here, clean up a little bit. So VF squared on the left side of the equal sign stays, 2A delta X, but therefore to find A, we divide both sides by 2 and delta X. So we have a function for A. So A here is equal to VF squared over 2 delta X. Well, we know what VF is. VF is in the diagram is 5 meters per second. And we're going to square that. And then 2 delta X here is 30 meters because it says you're going to push the crate for 30 meters long. Okay. Once you do that, 5 squared is 25, and then 2 times 30 is 60. And if you do 25 divided by 60, you should get a value of 0.42 meters per second square. Here I've chosen to include the direction because in this particular diagram, the crate is being pushed to the right of the screen, which is to imply the positive X direction. And because it because the part A didn't use the word magnitude, and that's just for the acceleration. Acceleration is a vector, so you do need to include direction. So here I included the plus sign to indicate that it is accelerating rightward. All right. To do part B, it says find the time to cover the first 30 meters. There's a bunch of different ways to do part B, so I'll show you a couple of different ways. But again, there's different ways. You figure out what works for you. To find the time, I think the easiest way to do it is just use the acceleration function. Acceleration is change in velocity over change in time. Here, part B asks us to find delta t, or the time. So delta t is in the denominator. In order to solve for a variable that's in the denominator, the first algebra step should be to get it in the numerator. So I want to multiply both sides by delta t to get it to the top. At the same time, though, I want to get rid of this a by dividing both sides by a. So I want to do 2 steps in one, or I like to tell you in this function just crisscross. Move the delta t up, move the a down. So delta t is change in velocity over change in velocity over acceleration. Okay. We can break up change in velocity as VF minus VI over acceleration. But here we know that VI is 0, so I'm just going to leave that out. Therefore, we know VF, VF is 5 meters per second, and then the acceleration that we calculated in part A is 0.42 meters per second square. So if you do 5 divided by 0.42, you should get a time of about, give take, 11.9 seconds. Okay, so that's our answer. All right. The other way to do it, if you like, is to use this particular displacement function. Why? Because it has a time in it. The variable t is present in this particular kinematics equation. Here, we know VI is 0, so we can just go ahead and cross that term out. Delta x here is 30 meters. It is positive 30, but here I'm just trying to find time, so direction doesn't really matter. So I'm just going to use 30 for delta x. The 1/2 is carried down. Acceleration here is 0.42 meters per second square because that's what we found in part A. And then here's t square. So the only variable that's unknown here is your t square. I'm just going to clean up a little bit. 1/2 times 0.42 is 0.21. And 0.21 t square. And then to get t square, divide both sides by 0.t1. So if you take 30 and divide it by 0.21, you should get a value of 142.86 about there. And then this is t squared though. So to find t, we square root both sides in order to get t by itself. and then the square root of 141.86 gives us about 11.9 seconds. So as you can see, the answer here are the same based on, regardless of which approach or with which method you decide to apply. All right, let's do part C. Excuse me. Let's do part C. Part C asks us to find the coefficient of kinetic friction mu k. So right away, if it asks you to find mu k, I highly suggest that you start with the physics function that involves mu k. So mu k by definition is f of k over f of n. Here, we need to identify what f of n is. For this particular diagram, the red arrow that just came up on your screen is f of g, aka the weight. So f of g, which is your weight, by definition is mass times gravity. But there is a counter force pushing up on the box. So again, the weight of the box is pushing down on the surface, but the surface pushes back up because the acceleration in the y direction is 0. So the box is to remain in contact with the floor. Therefore, it is not accelerating up or down, which means the force in the y direction has to be perfectly canceled. So if you have an arrow down, there must be an arrow pointing up. That arrow pointing up is the force exerted by the surface onto the box. That's called the normal force. So therefore, we have mu k is equal to fk over f of n, but f of n in this case would just be 40 newtons because the weight of the box or crate here is given as 40 newtons. Again, so it's important that you pay attention to units. This says 40 newtons, not 40 kilograms. So 40n represents f of g already. So f of n is f of g. So wherever f of g is, I can just plug in 40 newtons, okay? Therefore, to find f of k though, the only thing I'm missing in the statement is f of k. To find f of k, I can just set up Newton's second law in the horizontal direction. It's important that you recognize as the crate is being pushed to the right, the surface is rough, so therefore there has to be an opposing force acting against the motion of the crate. Here in this particular problem, I drew the arrow blue pointing leftward because the crate is being pushed rightward. So therefore, the force of kinetic friction has to be opposing it, which is pointing leftward. So I'm just going to set up Newton's second law for that. I have F minus F of k. So here's F minus F of k, which equals to the mass times acceleration. I know what my F is. My F is 16. What I do know is that I don't know what my mass is. Okay, so I don't know what my mass is, so I can find what my mass is. We already are given the weight of the system. So on the bottom here, excuse me, F of g here is equal to mass times gravity. But we can find mass super quick, simply dividing both sides by g. So here's f of g divided by g, which is equal to mass. But we know the f of g value. F of g is given in the diagram as 40 newtons, okay? And then g we know is 9.8. So therefore, I can plug in 40 newtons divided by 9.8, and that will give me mass. So the mass here is about 4.08 kilograms. So therefore, I can substitute this in, okay? Here F is 16 newtons. The mass I just found is 4.08 kilograms. The acceleration is found on part A, which is 0.42. And here the only thing that's unknown is my f of k. So if I simplify this on my calculator, I should get 16 minus 1.71. And then we simplify that further, we should get a value of 14.29 newtons. Well, I'm missing f of k up here, and I just found f of k by just setting up Newton's second law in the horizontal direction. So therefore, I can substitute this in for f of k. So wherever f of k is, I can plug in 14.29, and then therefore the numerator is now 14.29, and then here we just do calculator. 14.29 divided by 40 is simply 0.36 newtons, okay? And I'd like to point out and remind you that the coefficient of kinetic friction has no unit and it has no direction. So the answer would simply be 0.036, okay? I hope that helps. Stay nerdy, don't be whack.